Congratulations, you've reached question number 6 of our review from the 2013 FRQs. So this is our differential equation question. Because it has a derivative in it, that means it is a differential equation. F of x is a solution, so we get to a solution by doing an antiderivative, integrating. And we know that our solution is going to go through 1.0 or 1 comma 0. Part A, though, we're not ready to separate our variables yet. Part A says first find a line tangent to the graph of our solution curve at 1.1 comma 0. So a tangent line equation, first we need a slope. Well, that's what dy dx is the slope. The slope of the tangent line is the derivative, so we simply have to find e to the 0. 3 times 1 squared minus 6 times 1. So e to the 0 is 1 times negative 3. So there's the slope of our tangent line. So our tangent line will have the equation y minus 0, which of course you don't need to write, the minus 0, x minus 1. So you could write that either way. And then we want to use that to approximate f of 1.2. So the tangent line is going to be close to the solution curve. So we're going to and what I wanted to write there is to let y be equal to 1.2. Sorry, I wanted to let x be equal to 1.2. So we're going to put 1.2 in here, and we will come up with negative 3 times 0.2 or negative 0.6. And that is our approximation for our solution curve. We're assuming it's going to stay pretty close to the tangent line. So that's only an approximation, definitely not equal to f of 1.2. All right, part B now says go ahead and actually find out what f of x is equal to at this initial point. So we're going to take our derivative that was given. All right, one more try here. So we were given dy dx is equal to e to the y times 3x squared minus 6x. So to solve this, we're going to do separation of variables. So I'm going to move the e to the y to the other side. And you might write that as e to the negative y right away. Separation of variables. Make sure you show that step on your paper. And then we're going to integrate each side. So this is e to the y, negative y. So remember that when we integrate this, e to the negative y is almost its own derivative, but there would have been a chain rule of negative 1. So let's put a negative out here. That might be a u du substitution for some of you, but I think many of you now have the idea that you can compensate for that chain rule there. We could add a constant to that side, or we could say that we're just going to combine the constants on the right-hand side immediately. So I'm going to use power rule on these two terms, and then I'm going to be making some changes, so I'm going to call that a C1 for now. Right away, I think I'll multiply through by a negative. And then I could change that to minus C1, but I think instead I'll just call it C2. So C2 is the opposite of C1. Sooner or later we have to find out what our constant is, so you could keep doing some more work. We want to solve this for y, so we're going to take the log of both sides. So you might say, well, before I take the log of both sides, this might be a good time to substitute to find out what c is equal to. You can either do that now or you can do that later. So we're going to have 0, opposite of 0 in there for y, and we're going to have a 1 in here, so we'll have a negative 1 plus a 3. And here we'll have, oh goodness, let me pause and get my tablet straightened out again. So let me say that again here. So we've got a 1 for e to the 0. And over here we've got a 2 plus a C 2, so our constant, whatever you call it, is going to be a -1 at this point. So we have e to the -y is equal to -x cubed plus 3x squared minus 1. And now we still want to solve this for y. Notice, by the way, that this value on the right-hand side is positive since it's equivalent to e to a power. So this right-hand side, later we can make a note that we know that this is going to be the positive value. And if we take natural log of both sides to get that exponent out of there, then we're almost done. I don't need this. I know this is positive. And then we can multiply both sides by negative, and then I think we're finished. So we might make a point here to clarify, since we've got this issue with natural log. You might say that we know that we want -x cubed plus 3x squared minus 1 to be greater than 0, since it passes through, and it passes through the point 1, 0. And I don't think that was already given in the problem, so I don't think that students will be held accountable to add such a note. But if you see it on the scoring rubric, you'll know what that applies to. And I think that's all we need to do here.